October 29th, 2025. An interstellar visitor reaches the moment of truth. Behind the blinding glare of our Sun, hidden from every telescope on Earth, the object designated 3I Atlas completes half its journey through our solar system. At exactly 7:47 a.m. Eastern Time, it sweeps to within 203 million kilometers of the solar surface, closer to our star than Earth itself. The timing is exquisite, the positioning suspicious, and for Harvard astrophysicist Avi Loeb, this moment represents what he calls the acid test, the definitive moment when we'll discover whether humanity is witnessing a natural comet or something far more extraordinary. 8 documented anomalies, a trajectory that defies statistical probability, and a rendezvous with the Sun that occurs precisely when Earth's observers are rendered blind. The answer to what 3I Atlas truly is begins unfolding right now, in the crucible of Perihelion, where solar radiation hammers its surface with 770 watts per square meter, and the laws of orbital mechanics create the perfect window for technological maneuver. The discovery came on July 1st, 2025, when the Asteroid Terrestrial Impact Last Alert System, ATLAS for short, detected a new object streaking through the inner solar system. Within hours, the initial data triggered a cascade of observations that would transform this from routine discovery to global fascination. The object was moving fast, roughly 44 kilometers per second, faster than either of the 2 previous confirmed interstellar visitors, the enigmatic 1I Oumuamua that puzzled astronomers in 2017, and 2I Borisov, the more conventional interstellar comet discovered in 2019. But speed alone doesn't make something special in the cosmic ocean. What stopped researchers cold was the trajectory. 3I Atlas is travelling on a hyperbolic orbit, meaning it's not gravitationally bound to our Sun. It arrived from interstellar space and will depart back into the void between stars. That makes it only the 3rd confirmed interstellar object ever detected passing through our solar system. The eccentricity of its orbit sits at approximately 6.1, a number that definitively marks it as an outsider, a cosmic traveller from beyond. Tracing its path backward through the celestial sphere, astronomers determined it originated from the direction of Sagittarius, near the dense star fields of our galaxy's centre. It came from the south, entering our planetary neighbourhood from below the ecliptic plane, that flat disk where Earth and the other planets orbit the Sun. Here's where things get genuinely strange. Despite arriving from a random point in interstellar space, where objects should approach from any direction with equal probability, distributed across the entire celestial sphere, 3 Atlas's trajectory aligns with the ecliptic plane to within just 5 degrees. Think about that for a moment. The Milky Way's disk sits tilted about 60 degrees, relative to our solar system's ecliptic plane. For an object arriving from the galactic neighbourhood to hit such precise alignment represents a statistical probability of roughly 0.2%, 1 chance in 500. When Avi Loeb and his colleagues ran the numbers, accounting for the random velocity dispersions of stars and the expected arrival angles of interstellar debris, they found this alignment deeply improbable for a natural object following a random trajectory. But alignment is just the first anomaly. As telescopes around the world locked onto 3I Atlas through July and August, they began detecting something that shouldn't exist: a sunward jet, what astronomers call an anti-tail. Normal comets, as they heat up approaching the Sun, develop tails that stream away from the solar wind and radiation pressure. Dust and gas get pushed backward, creating those magnificent sweeping plumes we see in photographs. 3I Atlas did the opposite. High-resolution imaging from the Hubble Space Telescope on July 21st revealed a pronounced jet extending toward the Sun, roughly 10 times longer than it was wide, resembling a focused beam more than a diffuse cloud. This wasn't an optical illusion caused by viewing angle, a phenomenon that sometimes creates the appearance of anti-tails in regular comets. Multiple independent observations confirm the jet's 3-dimensional structure pointed sunward, directly into the oncoming solar radiation that should be pushing material away. Eric Quito and Avi Loeb collaborated on a theoretical model to explain this bizarre behaviour. They proposed that carbon dioxide sublimation from the nucleus could eject ice fragments that scatter sunlight preferentially in the forward direction, creating the illusion of a jet pointing toward the Sun. It's an exotic explanation, invoking processes rarely if ever seen in natural comets, but it remains within the bounds of known physics. By September, the anti-tail had weakened, and a more conventional tail began developing, adding another layer of complexity to the object's behaviour. The transition itself became a subject of intense study, with researchers attempting to model the forces that could produce such a dramatic shift in emission patterns over just a few weeks. The third anomaly concerns sheer mass and size. Early photometric observations suggested 3I Atlas might have a diameter exceeding 12 miles, roughly 20 kilometres. Later refinements using data from NASA's Spherex Space Observatory and the James Webb Space Telescope narrowed that estimate to a minimum of about 5 kilometres in diameter. Even at the conservative end, this makes 3I Atlas monumentally larger than the previous interstellar visitors. Oumuamua measured perhaps 200 metres at most, a cosmic pebble by comparison. 2I Borisov was slightly larger but still dwarfed by this new arrival. Based on reasonable assumptions about density and composition, 3I Atlas carries a minimum mass of approximately 33 billion tons. That's 1 million times more massive than Oumuamua and 1,000 times heavier than Borisov. The probability of encountering such a massive interstellar object, travelling at such high velocity, arriving at this particular moment in human history, comes out to less than 0.1%, according to models of the interstellar object population. Now we arrive at the chemistry, and this is where things get truly weird. Spectroscopic observations from multiple facilities, including the Very Large Telescope in Chile, the Keck Observatory in Hawaii, and the James Webb Space Telescope, all converged on a shocking composition profile. The gas plume surrounding 3I Atlas is dominated by carbon dioxide, roughly 87% by mass, with traces of carbon monoxide making up another 9%, and water accounting for most of the remaining 4%. This is essentially inverted from what astronomers expect in comets, which typically consist primarily of water ice, with lesser amounts of other volatiles. 2I Borisov, the interstellar comet that preceded 3I Atlas, showed a composition much closer to solar system comets, water-rich and chemically familiar. But the real bombshell came from the metallic emissions. Comets occasionally show traces of metals in their spectra, typically iron and nickel together, products of ancient supernova explosions incorporated into the primordial material from which comets form. These metals shouldn't sublimate at the low temperatures of typical comets, making their presence puzzling even in normal circumstances. 3I Atlas shattered all precedent. Spectroscopic data revealed prominent nickel emission lines but no detectable iron whatsoever. This nickel without iron signature has never been observed in any natural comet, either from our solar system or interstellar space. The only place such a chemical profile exists on Earth is in industrially produced nickel alloys, created through a specialized process called the carbonyl pathway. The carbonyl process refines nickel by forming and then decomposing nickel tetracarbonyl, a compound with the formula NiCO4. It's a technique developed in industrial metallurgy specifically because it separates nickel from iron with high efficiency. The researchers who analysed the 3I Atlas spectra proposed that this carbonyl chemistry might be occurring naturally near the nucleus, driven by the unusual carbon-rich environment. They calculated that nickel production was running at approximately 5 grams per second, at a heliocentric distance of about 2.8 astronomical units, with the rate climbing sharply as the object approached the Sun. Meanwhile, cyanide emissions measured about 20 grams per second, creating an unprecedented nickel-to-cyanide ratio that places 3I Atlas far outside the range of any known comet population. Imaging from the Keck Cosmic Web Imager captured the spatial distribution of these emissions. Narrow-band images isolating nickel and cyanide wavelengths revealed that nickel concentrates strongly near the nucleus, while cyanide extends more diffusely. If the carbonyl process is indeed occurring, theory predicts exactly this pattern, with nickel tetracarbonyl forming close to the nucleus where carbon dioxide and carbon monoxide densities are highest. It's theoretically possible, but it requires invoking an exotic chemical pathway that has never been confirmed in any other astronomical object. The alternative interpretation, one that Avi Loeb continues to emphasize, is that we're looking at a refined metallic surface or exhaust from technological processes. The fifth anomaly involves polarization, the way light becomes oriented as it scatters off the object. When sunlight bounces off dust and ice in a comet's coma, it acquires specific polarization signatures that depend on the composition and structure of the scattering particles. Astronomers have catalogued polarization behavior for hundreds of solar system comets, creating well-defined categories. 3i Atlas fits none of them. Observations revealed an extremely deep negative polarization of -2.77% at a phase angle of 6.41 degrees, with a low inversion angle where the polarization changes sign at just 17.5 degrees. This combination of properties has never been measured in any comet, interstellar or otherwise. The extreme negative polarization suggests particle properties or surface textures completely unlike anything in the astronomical catalogue, potentially indicating exotic materials or geometries that don't occur in natural ice and dust mixtures. Anomaly 6 concerns the fine-tuned trajectory that brings 3i Atlas within close range of multiple planets, while remaining unobservable from Earth during the critical perihelion window. On October 3, 2025, the object passed within just 29 million kilometers of Mars, close enough that NASA's Mars Reconnaissance Orbiter and ESA's Mars Express were positioned to capture unprecedented high-resolution data. Then came solar conjunction on October 21st, when 3i Atlas moved directly behind the Sun as seen from Earth, rendering it invisible to ground-based and most space-based telescopes for more than 2 weeks. 8 days later, on October 29th, it reached perihelion at 203 million kilometers from the Sun, still hidden behind the solar glare. After perihelion, it will pass just 97 million kilometers from Venus on November 3rd, then make its closest approach to Earth at 267 million kilometers on December 19th, exactly 6 days before Christmas. Finally, on March 16, 2026, it will sweep within 54 million kilometers of Jupiter, where NASA's Juno spacecraft will be positioned for detailed observations. The probability that a randomly arriving interstellar object would naturally execute this planetary tour, hitting optimal observation distances for Mars, Venus and Jupiter while remaining hidden from Earth during perihelion, is vanishingly small. Avi Loeb calculated the combined probability at roughly 0.05%. Add in the ecliptic alignment, the unprecedented mass, the chemical anomalies, and the polarization behavior, and the cumulative odds of all these factors occurring together by chance stretch to roughly 1 in 10 quadrillion. These are lottery-winning every day for a year levels of improbability. The seventh, and perhaps most speculative anomaly, connects 3i Atlas to one of the enduring mysteries of the search for extraterrestrial intelligence. In August of 1977, the Big Ear Radio telescope at Ohio State University detected a powerful narrowband radio signal that lasted 72 seconds, far stronger and more precisely tuned than background noise. Dubbed the WOW signal for the excited notation written by astronomer Jerry Eman on the computer printout, this transmission has never been satisfactorily explained. It appeared to originate from a region of sky in the constellation Sagittarius, and despite decades of follow-up observations, it is never repeated. When astronomers traced back the trajectory of 3i Atlas through interstellar space, they found it originated from a direction just 9 degrees away from the WOW signal source. The angular separation represents a coincidence probability of roughly 0.6%. Is this meaningful? Probably not. But it adds one more intriguing data point to an already extraordinary puzzle. The eighth anomaly emerged just days before perihelion, new images captured by space-based solar observatories as 3i Atlas approached its closest solar pass revealed rapid brightening far exceeding the rates typical of Oort cloud comets at similar distances. Even more striking, the object was appearing bluer than the Sun itself in visible light wavelengths. This violates basic expectations. Dust should redden scattered sunlight through standard scattering physics. The surface of a comet nucleus, orders of magnitude colder than the Sun's 5,800 degree Kelvin photosphere, should produce a distinctly redder color profile. Instead, 3i Atlas was glowing with a blue-shifted spectrum suggesting either an internal heat source hotter than the Sun or exotic scattering processes completely outside the realm of known cometary physics. All of these anomalies, catalogued and quantified, earned 3i Atlas a rank of 4 on the Loeb scale, a classification system developed to assess the potential technological origin of interstellar objects. The scale runs from 0, definitively natural, to 10, definitively technological. A rank of 4 sits in the ambiguous middle ground, unusual, anomalous, worthy of serious investigation, but not conclusive. A.V. Loeb has been careful to emphasize that 3I Atlas is most likely a natural comet, perhaps the most exotic natural comet ever observed, but natural nonetheless. The rank of 4 reflects a 30 to 40% subjective probability that the object might not have a fully natural origin. That leaves a 60 to 70% chance it's just a very weird rock covered in very weird ice executing a very unlikely trajectory. But given the stakes, even a 30% chance demands rigorous investigation. This brings us to October 29th, 2025, and the concept of the acid test. In chemistry, an acid test uses acid to determine the purity of gold. In space exploration, Perihelion represents the acid test for comets because it subjects them to maximum thermal stress. At 203 million kilometers from the Sun, 3I Atlas is absorbing roughly 770 watts of solar radiation per square meter, enough to rapidly heat and sublimate surface ices. If the object is a natural comet held together by weak intermolecular forces between ice grains, this intense heating could fracture and fragment the nucleus, causing a dramatic brightening as fresh surface area gets exposed and volatile materials evaporate more efficiently. Many comets break apart near perihelion, unable to withstand the thermal shock. If 3I Atlas is natural, astronomers expect to see significant changes in brightness, morphology, and outgassing patterns as it emerges from behind the Sun in early November. But if 3I Atlas were technologically manufactured, perihelion offers something entirely different, an optimal maneuver window. This is where orbital mechanics and the Oberth effect come into play. The Oberth effect is a fundamental principle of spaceflight first described by the German physicist Hermann Oberth in 1929. It states that a rocket engine produces maximum change in kinetic energy when fired at the moment of highest velocity. For a spacecraft on a hyperbolic trajectory past the Sun, that moment occurs at perihelion. The physics is elegant and counterintuitive. When travelling at 68 km per second, the peak velocity through Atlas achieves at perihelion, every joule of propulsive energy translates into roughly 4,124 joules of mechanical energy change. This is why modern spacecraft use gravitational assists, slingshot maneuvers around planets to gain velocity, boosts far exceeding what their engines could provide through direct thrust alone. If 3I Atlas were a massive carrier vessel, a mothership in Loeb's terminology, perihelion would be the logical moment to deploy smaller probes toward inner solar system destinations like Earth, Venus, or Mars. The math is unforgiving. To transition from an escape trajectory to a solar-bound orbit requires velocity changes on the order of 32 to 44 km per second, depending on the target orbit. That's equivalent to the energy budget of multiple Apollo missions. For a 5-kilometer mothership to execute such a maneuver would require propellant mass potentially exceeding the object's entire mass, even with theoretically optimal rocket efficiency. But for small probes released during perihelion, perhaps just meters across and massing only tons rather than billions of tons, the energy requirements become manageable. Release them with precisely calibrated velocity kicks during the Oberth window, and they could reach Earth orbit within a few months using gravitational assists and minimal onboard propulsion. Loeb's hypothesis isn't that 3I Atlas will maneuver itself, it's too massive. The hypothesis is that if technological, it might release secondary objects, mini probes that exploit the perihelion window for maximum efficiency course changes toward planetary targets. The Sun's tidal forces would gradually separate these deployed objects from the mothership over subsequent weeks and months, creating distinguishable trajectories detectable through careful observation in November and December. This is a testable prediction. If 3I Atlas is natural, it should emerge from perihelion following a purely gravitational path, perhaps with some small non-gravitational accelerations from outgassing, but nothing dramatic. If it's technological and active, we might detect secondary objects with anomalous trajectories, excess heat signatures from engines, radio transmissions, or visual anomalies like artificial lights. The blackout window adds an element of cosmic drama. From October 21st through early November, 3 Atlas is positioned such that the Sun sits between the object and Earth. making direct observation impossible from our planet. Some space-based solar observatories like Stereo A, SOHO, and the Punch constellation can glimpse the object in their coronagraph fields, but these instruments are designed to study the Sun's outer atmosphere, not to conduct detailed spectroscopy and imaging of faint comets. The blackout represents a genuine observational gap at exactly the moment when any technological maneuver would most likely occur. Was this timing coincidental, or was it by design? Avi Loeb has openly asked whether an advanced civilization planning an interstellar reconnaissance mission would deliberately time the trajectory to minimize observation during critical operational phases. It's a provocative question with no definitive answer, but it highlights how the alignment of orbital mechanics and observational geometry creates circumstances that are, at minimum, deeply convenient for avoiding detection. The International Asteroid Warning Network, a global coalition coordinating observations of potentially hazardous objects, initiated a comprehensive monitoring campaign for 3I Atlas in early October. This coordination involves ground-based telescopes across multiple continents, space telescopes including Hubble and Webb, and spacecraft assets including JUICE en route to Jupiter, NASA's Juno orbiter, and the Mars Reconnaissance Orbiter. Avi Loeb also tasked the research team at the Galileo project, his initiative to search for evidence of extraterrestrial technology, to monitor for unusual atmospheric phenomena around Earth in the coming months. The Galileo project operates 3 dedicated observatories designed to detect and characterize anomalous aerial objects, essentially a scientific approach to the UAP question. If 3I Atlas were to deploy probes toward Earth, the Galileo sensors might provide early warning. US Congresswoman Anna Paulina Luna has been working behind the scenes to ensure transparency and data sharing. She sent a letter to NASA administrators requesting the release of high-rise images captured by the Mars Reconnaissance Orbiter when 3I Atlas passed Mars on October 3rd. Those images, with a spatial resolution of approximately 30 kilometers per pixel, should provide the clearest views yet of the object's nucleus and coma structure. As of the Perihelion date, those images have not been publicly released, sparking criticism from Loeb and others who argue that data of this significance should be immediately shared with the global scientific community. The delay might be innocent, caused by the time-consuming process of data calibration and peer review, or it might reflect institutional caution about releasing information on an object that has generated significant public speculation. What happens next depends entirely on what 3I Atlas does in the coming weeks. If it's a natural comet, we should see it re-emerge from behind the Sun in early November, with enhanced brightness from perihelion heating, perhaps showing fragmentation or outburst activity typical of comets under thermal stress. Spectroscopic observations should reveal changes in the gas production rates and composition as different ices sublimate at varying temperatures. The trajectory should remain purely gravitational, with perhaps minor perturbations from outgassing momentum. By mid-December, when it makes its closest approach to Earth at 267 million kilometers, telescopes worldwide will have had weeks of continuous observation to characterize every detail. If 3 Atlas is something more than natural, the signatures would be unmistakable. Any significant deviation from the predicted gravitational path would indicate active maneuvering. The detection of secondary objects separating from the main body would be strong evidence of deployment. Radio emissions beyond the background thermal radiation expected from a warm surface would suggest technological activity. Excess heat signatures inconsistent with solar heating alone would point to internal energy sources. Visual anomalies, particularly lights, or geometric structures visible in high-resolution imaging would be definitive. None of these signatures have been detected yet, but the observational window is just beginning to open. The JUICE spacecraft, ESA's Jupiter Icy Moons Explorer currently en route to the outer solar system, will pass within 64 million kilometers of 3I Atlas on November 4th, just days after perihelion. JUICE carries a suite of instruments including the Janus Visible Imager, MAGIS infrared spectrometer, and TSWI submillimeter wave instrument capable of analyzing gas composition and surface properties. This represents the first dedicated spacecraft encounter with 3I Atlas, providing data at resolutions and wavelengths impossible to achieve from Earth. NASA's Juno spacecraft orbiting Jupiter will get an even closer look on March 16, 2026, passing within 54 million kilometers. Juno's UV spectrograph, infrared mapper and microwave radiometer can characterize outgassing patterns, thermal emission, and even search for radio transmissions that might constitute technological signatures. The scientific process demands skepticism proportional to the extraordinary nature of the claim. The hypothesis that 3i Atlas might be technological requires extraordinary evidence, not just statistical improbabilities and chemical anomalies. The default assumption must remain that this is a natural object, however exotic its properties may be. But the scientific process also demands thoroughness. When an object displays 8 distinct anomalies, each one pushing the boundaries of known cometary behavior, it earns rigorous investigation regardless of the implied conclusions. This is the essence of Loeb's argument. Not that 3i Atlas is definitely alien technology, but that the possibility must be taken seriously enough to warrant comprehensive observation and transparent data sharing. The broader context matters here. We live in an era where the search for extraterrestrial intelligence has moved from fringe speculation to mainstream science. The Breakthrough Listen initiative scans millions of stars for radio and optical technosignatures. NASA has established a formal UAP study team to investigate anomalous aerial phenomena. The Vera Rubin Observatory, scheduled to begin full operation soon, will discover thousands of interstellar objects in the coming decade, providing statistical context that currently doesn't exist. If intelligent civilizations are common in our galaxy, some fraction of them might have sent probes or artifacts into interstellar space, and statistical arguments suggest we should encounter them occasionally. 3 Atlas, with its unprecedented collection of anomalies, represents the kind of object that demands close scrutiny under this framework. There's also a practical element. If the object were technological and potentially hazardous, early detection and characterization would be critical for planetary defense planning. Loeb has co-authored white papers submitted to the United Nations, arguing for coordinated global monitoring of anomalous interstellar objects, precisely because the consequences of missing a genuine threat are so severe. This isn't about alien invasion paranoia, it's about recognizing that our solar system sits in an open cosmic ocean where we've barely begun to understand what might be drifting through. The statistical arguments suggest most interstellar objects should be natural debris, fragments from planetary systems, leftover construction material from the star formation process. But most isn't all, and until we've catalogued thousands of these visitors, we can't claim to understand the population. The timing of Perihelion, 2 days before Halloween, has not been lost on observers. Loeb himself has asked the question rhetorically, is 3 Atlas wearing a costume, appearing as a comet while hiding something else beneath? It's evocative language, chosen deliberately to capture public imagination. The reference to the Trojan horse, a gift that concealed warriors who destroyed Troy from within, frames the question in civilizational terms. If an advanced intelligence wanted to deliver a payload into the inner solar system while minimizing detection, disguising it as a natural comet would be brilliant strategy. The ice and gas coma provides natural camouflage. The hyperbolic trajectory ensures it's only observable for a limited window. The timing to place perihelion during solar conjunction adds an extra layer of concealment. It's a scenario that would make sense from an engineering perspective, which doesn't mean it's what's actually happening, but it means we shouldn't dismiss the possibility without rigorous investigation. As 3i Atlas re-emerges into observational view in the coming weeks, the global astronomical community will be watching with unprecedented attention. Ground-based facilities like the Keck telescopes, the Very Large Telescope, Gemini observatories and dozens of smaller instruments will track every detail of brightness, spectrum and position. Space telescopes will provide ultraviolet and infrared data inaccessible from the ground. Spacecraft in position throughout the inner solar system will offer viewing angles impossible from Earth. All this data will be analysed compared to theoretical models and eventually published in peer-reviewed journals where other scientists can scrutinise the methodology and conclusions. The answer to what 3i Atlas truly is will likely remain uncertain for months. Science rarely offers immediate definitive answers to complex questions. But by December, when the object makes its closest approach to Earth, we should have enough data to significantly narrow the possibilities. If the anomalies persist, if new anomalies emerge, if the object behaves in ways that continue to defy natural explanations, then Loeb's rank of 4 on the technological scale might need revision upward. If instead the object settles into conventional cometary behavior, showing all the expected signatures of ice sublimation and thermal stress response, then the rank drops toward the natural end of the scale. Either outcome advances our understanding. Either outcome teaches us something profound about the universe we inhabit. The real lesson of 3i Atlas, regardless of what it ultimately proves to be, is methodological. When something appears that doesn't fit our existing categories, the correct scientific response is careful observation, transparent data sharing, and openness to multiple working hypotheses. Dismissing anomalies without investigation is as unscientific as jumping to conclusions without evidence. The cosmos is vastly more complex than our current models can capture. Every generation of astronomers has discovered phenomena their predecessors didn't predict and couldn't explain with existing frameworks. Black holes, pulsars, gamma-ray bursts, dark energy, fast, radio bursts, all these were once anomalies that demanded new physics to understand. 3i Atlas sits in that tradition, a puzzle demanding explanation whether the answer is exotic natural processes or something more extraordinary. So we watch, we wait, we gather data, we follow the evidence wherever it leads, and we remember that the universe has surprised us before and will certainly surprise us again. The acid test of 3i Atlas at Perihelion is complete. The object has passed through the crucible of solar heating while hidden from Earth's view. Now comes the moment of truth, when it emerges back into observational range and reveals whether it survived perihelion as a natural comet, or whether it's carrying secrets that will reshape our understanding of our cosmic neighbourhood. If you found this deep dive into the 3i Atlas mystery fascinating, please consider subscribing to Tales of Gravity. Hit that like button to help this video reach more people curious about the boundaries of astronomical discovery. Drop a comment below sharing your thoughts on whether you think 3i Atlas is natural or potentially something more, and what you think the next few months of observations will reveal. The universe is vast, strange, and full of wonders we're only beginning to understand, and this channel is dedicated to exploring those mysteries with scientific rigour and genuine curiosity. Thanks for watching, and keep looking up.